Another nice example is to explain to students how sine and cosine are applied in real life. As we did the business example before, now I'm going to talk about waves. There's so many things that behave as a wave. Every time a student uses their cell phone, there's a wave involved, yeah? Now when you use a cell phone up to your ear, I know, I should have taken more art, but that's the best I can do. Well, I can do a little better, okay? So for a cell phone, you got your cell phone up here, you know, you're listening to it on your ear. The wavelength is really long. It's a long wavelength. So when you're on the phone, the wave just kind of goes through. It doesn't interfere with very many molecules and atoms in your body. But so the radio wave is very long for a cell phone type of wave. Now when we go to the hospital, we get a broken bone or something, we need an x-ray. They look at our bones. An x-ray is very, very short and goes up and down a whole lot of times in a very short distance. And when it goes through our body, because it's going up and down a whole lot, it interferes with our bones and everything, and that's why you can see the bones when you get an x-ray. But this also explains why x-rays are not very good for us, especially for little children. At least you don't want a lot of x-rays. Why? Because when you get an x-ray, it interferes with the cells in your body, and when a kid's growing, the cells are changing a lot, yeah? And that interference can affect how the cells go about changing. Once we're older and our cells don't, we aren't growing, our cells aren't changing as much, it's not quite as much of a big deal. But this explains why a cell phone versus an x-ray, the difference, and why one isn't really that bad, but another one, extended exposure to x-rays can be potentially very harmful.